We're going to look at the first and second derivatives of parametric equations. We have x equals 2t squared and y equals t to the power of 4 subtract 2t squared. These are both defined in the parameter t. So we take the derivative of x with respect to t, dx dt, in the usual way, 4t, and the derivative of y with respect to t is 4t cubed subtract 4t. To find dy dx, we'll have to divide the derivative dy dt by the derivative dx dt. That means 4t cubed subtract 4t is divided by 4t. Now there's a common factor of 4t in the numerator, which we can take out. 4t multiplied by t squared is the original 4t cubed. Subtract 1 divided by 4t. So the 4t's cancel top and bottom, and we're left with t squared subtract 1 is the first derivative. We'll write it here. Dy dx is equal to t squared subtract 1. To take the second derivative, we must differentiate dy dx again. The right hand side, to differentiate with respect to x, remember this is defined as the parameter t. So we have to use the chain rule here. To differentiate a function of t with respect to x, the x and the t, we're going to have to differentiate the t squared subtract 1 by dt, because it's a function of t, then multiply by dt dx. So it's really just the chain rule to get the second derivative. T squared subtract 1, the derivative is 2t. dt dx, we don't actually know dt dx, but what we do know is dx dt, which is a fraction upside down. Now you can treat this derivative dt dx or dx dt as a fraction. So if we know dx dt over here is 4t, then dt dx is just 1 over 4t, upside down. It's reciprocal. So we just need to multiply 2t by 1 over 4t, 2t over 4t, and then the t's cancel, top and bottom, 2 over 4 equals a half. So in the end, the second derivative, d squared y dx squared is equal to half. This time we'll take the first and second derivatives of the parametric equations x equals e to the power of t and y equals t cubed plus t sub add 1. First derivative, dx dt, e to the t stays the same when you differentiate, and dy dt, differentiate 3t squared plus 1. dy dx, we divide 3t squared add 1 by e to the power of t. That's our first derivative. So to take the second derivative, d squared y dx squared, we need to differentiate with respect to t this function 3t squared plus 1 over e to the t. Then multiply by dt dx, it's just the chain rule. Now the first function, we have to use the quotient rule. So we differentiate the numerator, 6t, and multiply by the denominator left alone, e to the t. Then subtract 3t squared plus 1 left alone, multiplied by the derivative of the denominator, which is just e to the t, divided by the denominator squared, e to the 2t. Multiply by dt dx. We know that dx dt is e to the t, so its reciprocal is 1 over e to the t. Tidying up these terms on the next slide. Second derivative. We had 6t e to the t, subtract 3t squared, add 1, multiplied by e to the t. Now in the denominator we had e to the 2t multiplied by e to the t, which is e to the 3t. Multiplying the terms in the numerator, we have 6t e to the t minus 3t squared e to the t minus e to the t over e to the 3t. So each of these terms has a factor of e to the t, the numerator. Factorise by taking e to the t out as a common factor. 6t subtract 3t squared, subtract 1, all divided by e to the 3t. So we can cancel e to the t and change this to 2t. And that's the final answer. So stop at this stage. In this equation, x equals t cubed and y equals t squared subtract t, we're going to find the stationary point and determine its nature. So we start by finding dx dt, which is 3t squared, and dy dt, which is 2t subtract 1. Divide these to get dy dx, the first derivative. So 2t subtract 1, all divided by 3t squared. Now, for stationary points, this must be equal to 0. So write equals 0 for SPs. The numerator must equal 0 for stationary points to exist, so 2t subtract 1 equals 0. So this means 2t equals 1 and t equals a half. There's one stationary point when t equals a half. So to find the coordinates, we put t equals a half back into x and y, the original equations. So x equals t cubed, so it's a half cubed, cube the numerator and denominator, 1 over 8. And y would be a half squared, subtract a half, a quarter, subtract a half, which is negative a quarter. This is the stationary point. It's SP at 1/8, negative a quarter. In the next slide, we'll determine its nature. We'll have dy dx, the first derivative, is equal to 2t subtract 1 all upon 3t squared. So we have to differentiate this with respect to t and multiply by dt dx. It's probably easier just to individually divide by 3t squared rather than doing the quotient rule. 3t squared. And rearrange this. So we've got 2/3. We'll put t with a negative power. That's t to the 1. 1 subtract 2 is negative 1. Then negative a third, t to the negative 2. So the second derivative, we differentiate the above, negative 2/3 t to the negative 2, add 2/3 t to the negative 3, and multiply all of this by dt dx. Now we knew that dx dt was 3t squared. Just write this here. 3t squared. So its reciprocal upside down, dt dx is 1 over 3t squared. So we put 1 over 3t squared here. Just to do some algebra to tidy this up. Negative 2/3 t squared on the denominator, 2/3 with t cubed on the denominator, 1 over 3t squared. Now on the next slide I'm going to tidy up this and finish off finding out the second derivative and if it's positive, negative or 0. So we had the second derivative, continued from the last page, we had negative 2 divided by 3t squared plus 2 over 3t cubed in the bracket, multiplied by 1 over 3t squared. I'm going to deal with the terms in the bracket and put them all over a common denominator of 3t cubed. We'll need to multiply this fraction by t, top and bottom, in order for the denominator to be 3t cubed. So we have negative 2t plus 2 on the numerator there. We multiply this by 1 over 3t squared. Multiply the top, we have 2 subtract 2t, that's just writing it in the order so we're not leading with a negative term, and divide by 3 times 3 is 9, and t cubed times t squared is t to the power of 5. That's our second derivative. Now we'd like to know what happens to this when t equals a half. Remember, at the parameter t equals a half is our stationary point. So the second derivative, when t equals a half, we're just evaluating that. 2 subtract 2 times a half, all divided by 9 times a half to the power of 5. So we have numerator 2 subtract 1 is 1, and that's 9 multiplied by 1 over 2 to the 5, which is 32. So we have 1 over 9 over 32, which is 32 over 9. This is positive. So the second derivative equals 32 over 9, greater than 0, therefore it's a minimum turning point at t equals a half, and our coordinate is 1/8, negative a quarter. So that's how we do the second derivative of parametric equations to find the nature of turning points.